In this video tutorial, we are going to spend some time looking at different reports within Express. Express has several dozen different reports that can be viewed in a diagnostic study. However, for the purpose of this video, we will only look at a few of them. When we're in a diagnostic study, the Reports menu lists only the reports related to our diagnostics, or in this case, prognostics and diagnostics. We're going to take a look at the top 5 reports, the first 2 detection reports, and then the top 3 fault isolation reports. So the detection order report is the first one we're going to look at, and we're just going to use the default options. At the top we have a summary, and the key numbers to recognize is the total probability detected, which is the overall likelihood that if we have a failure it would be detected. It's using the failure rates that we entered into our model to project the likelihood that if a failure exists it would be detected. We also want to recognize the aggregate failure rate, which is the calculated failure rate based on all the different elements in the model and the subdesigns all rolled up into a single failure rate. This is important because we can compare it with our reliability estimates to make sure that our model and our reliability are on the same page. Underneath the summary we have the detection order. There are several different columns here, but we'll focus on the probability detected columns in the middle. This cumulative probability detected percentage adds up to match this number here. This column represents for each test which percentage of the system is actually proving good. By breaking down the total probability detected by test, this column allows you to see how many faults will be detected by each test in the fielded system. The second report we'll look at is the detection coverage report. And again, we'll just use the default settings. And what this report does is for each test it lists the coverage of that test in that place in the sequence. In this example, we use a diagnostic sequence that was trying to postpone detection until it proves as much of the system good as possible. And that's why our first tests in this list have such small coverage. If we scroll down, we can see that our later tests actually have a larger amount of coverage, which would require isolation to get to the final fault groups. So for each test, it gives us the name and lists the objects and functions that are detected by that test, along with the failure probability and our replacement cost and replacement time. So that gives us the information we need to investigate what each detection test is doing, how it came up with the number for testability, as well as the suspect set for which isolation needs to be performed. The coverage for each test in this sequence is dependent upon the sequence of the testing. Any test performed in a different sequence may typically produce a variance in the test coverage. For example, if we look at test 3, this is what is tested by this test when it's performed after these first 2 tests. So assuming that certain things have been proven good by the first 2 tests, this is what test 3 calls into suspicion. Also at the bottom are 2 very important lists. Here we get a list of functions not detected along with their relative failure probabilities. And here are the non-detected failure modes with both the failure probabilities and the maximum severity that failure mode maps to, which is critical. One of the things that we skipped over when we generated the report is the fact that we can sort the non-detected failures by failure probability by default, or we can sort it alphabetically if we turn that off. So if we have a long list of non-detection, we can sort it alphabetically and find a particular function more easily. Alright, now the next report we're going to look at is the main fault isolation report. This report has 2 main sections, although there are some optional sections that we can turn on. The 2 main sections are the fault group size statistics and the statistics to diagnose a primary failure. The multiple failure fault group statistics have 3 main sets of columns. The columns in the middle are those that correspond to the numbers that we were looking at in the fault isolation panel in the previous video. This is saying 50.46% of the time we will isolate to a fault group containing 1 component. 0.16% of the time we are going to isolate to a fault group containing 2 components, which means that 50.62% of the time we'll be isolating to a fault group of size 2 or less. This cum column is just a running total, so at the bottom here we should see 100 always because these are covering all of our different fault groups. Now the resolution probabilities on the right are saying not how well can the diagnostics isolate to a fault group of a certain size, but rather how well we are able to repair our system with a given number of replacements. So although we're only isolating to a fault group containing one component 50.46% of the time, if for whatever fault group we were to isolate, we were to replace the first listed component, which in this case is the item most likely to have failed since it's listing the components by failure probability, that will correct our problem 81.48% of the time. This page right here gives us some simplified maintainability calculations. Not so much to be able to provide true maintainability predictions as it is to measure the impact of our diagnostic changes upon maintenance. Let's focus on the cell in the lower right hand corner, the time to repair. In this cell, we are dealing with both how long it takes to isolate and replace the components at a given fault group. These numbers are based on attributes which we add and express. And when I referred to this as a simplified maintainability number, the reason is because it's only using one attribute on tests for the time to perform the test, and one attribute on each item representing the replacement time for that item. A true mean time to repair calculation involves a lot of different values. Here we're trying to simplify it so if we make changes to our diagnostics, we can see the impact upon maintainability, even though we can't really calculate maintainability until we have more information. So we're able to put in basic numbers for our test time and replacement time, and we can come up with an expected time to repair. Down here we've calculated an inherent availability based on that which is taking the mean time between failures and the mean time to repair into consideration to calculate this statistic. Alright, the second isolation report we will look at is the fault group rankings report, which we touched on a little bit in a previous video. This gives us the ability to look at which fault groups are contributing to certain behavior that we want to improve. For example, here's the fault group that contributes most to a long mean time to repair. If we were to click on this link here, it gives us the details for that fault group, meaning the functions, failure modes, as well as failure probability and replacement cost and time. And this can be evaluated to determine the best way to break up this fault group in order to improve our mean time to repair. Now, the last report we're going to look at is the fault group statistics report. By default, it's giving us precisely that per fault group data we were just looking at across all fault groups. So this is basically listing all fault groups. The functions are in magenta and the failure modes are in blue. So if we were testing failure modes, we're more likely to be isolating to specific failure modes. When we're testing for functions, we may not have enough information to break it down to the failure mode, but the key thing is that we're isolating to the part that we're repairing. And this report has a lot of options. You can include a lot of additional sections for each fault group. When we run the report, we can run the isolation sequence that led to isolating it. We can decide whether we want to include the inputs or outputs of the fault group. We can abbreviate things so that we're not listing the failure modes for functions, or we're only listing the items. So there's a lot of different ways we can customize this report as well. This concludes the brief overview of diagnostic reports within Express.